Alright, so starting with our two ways to find the net force. So one is our equation, F net equals mass times acceleration. And the other is to do the total of all the forces. So that can be adding or that can be subtracting depending on if their forces are in the same direction or opposite. To find the force of gravity, that is mass times g. G stands for the acceleration due to gravity. Little g is not a force on its own. Fg is a force when you multiply the mass times that acceleration. To find the force of friction, so that is equal to mu Fn, Fn being the normal force, mu being the coefficient of friction. So one note to make about this is for static friction, the force of friction might be less than the mu Fn, so it can be less than. And we will talk about, there's actually a couple problems where that is the case. Here, the difference between static and kinetic friction. So kinetic is for when the object is moving, and then we just use the force of friction equals mu Fn, like we're used to using. Static friction is whenever you're at rest, so when it is at rest, you must first overcome the force of static friction. It's a weird way to say that. If you have not done that, then it's possible that it's less than or equal to mu Fn. Again, only for static friction is it less. If it's already moving, your friction is definitely equal to the mu Fn. And you get different coefficients of friction when you're static or kinetic. The static coefficient of friction is always a little bit higher, and the kinetic coefficient is always a little bit lower. How do you find the direction of acceleration? If you know the way it's moving and if it is slowing up or speeding down. So v, the way that the object moves, that gives you your v. If v and a are the same direction, that means speeding up. And if v and a are opposite, that means it is slowing. So when you get the problems that are like, it is moving upwards and speeding up, velocity is upwards, speeding up means same direction, so a would be upwards in that case. Newton's third law says, for every action, there's an equal and opposite reaction. The way I want to think about it in here, that makes it easier for when I apply or not, is the force of A on B is the same as the force of B on A. So this is when you have two objects, they make a pair. The force between those two objects is the force between those two objects. So I give the example in class, like if I have me and I have Mr. O. And someone says, Mr. O is 5 yards away from me. And then someone says, how far are you away from Mr. O? Your answer is like 5 yards, right? It's the distance between them. There's no way he can be 5 yards from me and me not be 5 yards. It is the same distance. Similar idea here. So the force between A and B is whatever it is. So the force of A on B is that force, and the force of B on A is that force. It is the same force because it's the force between them. If an object is at rest, what do we know about the forces? They are balanced. If an object is moving at a constant velocity, we know the forces are balanced. So the free body diagram for at rest and constant velocity is actually the exact same. Remember, we can't tell motion from a free body diagram. We can only tell the direction of the acceleration, not the way it's moving. All right, we've got two blocks, frictionless surface, a force, there's an arrow there, it's just really light. 36 newtons is applied to X as shown. And I want to find the force of Y on X. So I want to find this force right here. I'm going to call it Fxy. That's my unknown right here. I saw people in class automatically go, ooh, 36 to the left. That would be, so let's say this was like my hand pushing it. If I said my hand pushed 36 on box X, then you could say box X pushes back 36 newtons on my hand. But that's not what I'm asking. I'm asking about Y on X. This is like whatever the outside force is. Let's say it's my hand. This is my hand on X. That does not have to be equal to Y on X, right? It's A and B and B and A. So the force of X on Y has to be equal to the force of Y on X, but that's not what the 36 is. So we're going to draw our free body diagram for the X. Gravity normal, for the Y, gravity normal. This is just for free response, so I'm not going to worry too much about like making this to scale, etc. I just care that it's going to accelerate to the red. So I have this 36 newtons. The 36 is acting on the x. It is not acting on the y because it is not physically touching the y, only the x. So I've got the 36 newtons right here. And then these two, right, obviously are pushing on each other, so there's going to be a force between them. So x will be pushing y to the right, and y will be pushing x to the left. So on x, I have it going to the left. Now we write our net force equation. So here my net force is equal to 36 minus fxy. Here my net force is equal to just fxy. Net force is ma. This one was 4a. This one is 20a. This is my fxy, so I can substitute in. This is just 4a is 36 minus 20a. Add over, that's 24a is 36. Divide, you get 1.5. That's my acceleration. I want to know the force exerted on by y on x. So that's this force right here, which we said was 20a. So plug a is 15, not 15, 1.5, you get 30 newtons. So now we're between these two. And we want to know by y on x. So y is pushing x to the left. So your answer is F. A person of mass m stands on a scale in an elevator. So whatever's happening, it definitely feels the force of gravity. And then now I'm looking for what the scale reads. So I'm looking for the normal force in each of these I guess, questions. So I just need to decide, is the normal force equal to mg? Is it more? Is it less? Is it 0? Etc. So each of these tells me which way it's moving, whether it's slowing down or speeding up. So I'm going to draw my velocity and acceleration arrows. Moving up, velocity up, moving down, velocity down. Right, now if I'm slowing, that means the acceleration is opposite to the velocity. So in this case, down. Here, opposite to the velocity because it's getting slower, so up. Speeding up, same direction as the velocity, so up. Speeding, same direction, so down. Constant speed means no acceleration, no acceleration. So these two are easy. If there's no acceleration, you know these forces are going to be balanced, so the force up will be equal to the mg, so that's B. Some people want to put D, your net force is 0. But if your net force is 0, you can't say the force up is 0, otherwise this would definitely be accelerating. So you definitely need a force up, it's just equal, balanced. Now, when I'm looking at my free body diagram, I pay attention to the direction of the accelerations. If I'm accelerating down, that means my bigger force is down, that means my F is smaller. So F would be less than mg if your acceleration is down. So this one, acceleration down, your answer is A. And then the next two have acceleration up. This one that has acceleration down is still this scenario, so it's still answer A. These two are accelerating up, which means if I still have mg, then the force up must be greater. So F greater than mg, which is C. So that's the case for both of these, where the acceleration is up. All right, number 3, we've got a mass of 100 kilograms. It's at rest on a horizontal floor. The coefficient of static friction is 0.4 and the coefficient of kinetic is 0.3. We've got an applied force of 344 parallel to the crate. What if the following is true? So basically it's asking what's happening. So here we've got friction. It says I'm starting for rest. So first I have to check my static friction. So if I were to draw a free body diagram, force of gravity is going to be, let's go ahead and calculate these, mass times g, so that would be 1,000. My normal force will be balanced, because it's not accelerating up or down. I've got an applied force of 344, and then I need to find my friction force first. I don't know if this is going to move or not. I don't know if it's like going to accelerate. So I'm going to find my static friction first because I'm starting from rest. So static friction is mu Fn. Static coefficient, static mu is 0.4. Normal force is 1,000. So this is 400 newtons. So this is the static force of friction. Now with static, we have to be careful because it's possible that it's less than or equal to. So if this is my static friction force and I push it at 344, this is not going to push back at 400 because this is not enough. 344 newtons is not enough to move. So this would be does not move. The friction force, if it does not move, would just be 344. The only reason we would get 400 is if I were to push with 400 or more than 400. and then it would start to move and it would go to kinetic. So here, because it started from rest, I had to check, did it overcome static friction? 344 did not overcome that, so it does not move. Here, we're going to draw our free body diagram. So gravity normal, T1. This one, gravity normal, T2. And then T1 pulling back. This guy, net force, the 2MA, is just equal to T1. Here, my net force, my 3MA, is equal to T2 that's supposed to be T1, minus T1. Now, I'm going to take this T1, substitute in, just like we've been doing. So 3MA is T2 minus 2MA. Add over, I get 5MA. So now I know that T1 is this, and I know that T2 is this. It is asking me to find T1. Notice that I have T1, right? It's 2MA, but A is not in any of my answers, but T2 is. So what I can do is I can solve for A right here, and just substitute that in for A. So this is 2M. A we just said was T2 over 5M. M's cancel. This is 2 over 5 T2. The other way to do it is to think of it as like the ratio of T1 over T2 would be this over this, which is 2/5. Some people would prefer that, doesn't matter, get the same answer. 5 is saying a ball of mass M is falling towards the earth. So a lot of people drew a free body diagram like this. They said mg. Maybe there's some air resistance, I don't know, but it's definitely accelerating down. And then it says the earth pulls down with the force of mg. And the ball pulls on the earth with what force? So this is the earth's force on the ball. And I'm asking, how does that compare to the ball's force on the earth? So here, this seems a lot like the force of A on B compared to the force of B on A. See how I have the exact same two objects, and I'm talking about the force between them? All I did was switch the order, A on B compared to B on A. And if you recognize that, then you think, oh, this is just Newton's law. It's the same two objects. It's talking about the force between each other. So that means equal and opposite, so your answer would be B. The ball pulls with the force of the earth pulls with the force of mg, and the ball would pull on the earth with the same force, just opposite. Now, what most people do is they go, if this is obviously not to scale, if this is the ball and this is the earth, the ball is the one that falls down. That's because the ball is a lot smaller. So we technically, like, the ball is pulling on the earth, but the earth is a lot bigger, so it doesn't actually go up. Now, when we talk about planets, when they're like closer to the same size, they actually do pull towards each other. So here they do pull with the same force. It's just the earth is super massive, so it doesn't actually move. All right, number 6, we've got a mass. It's on a horizontal surface. Kinetic and static coefficients of friction, and applied force of 260. What happens? So we're starting from rest, so I need to check, do I overcome static friction? So my force of gravity is mass times 10, so 500. So my normal force is also 500 here because it's balanced up and down. Force of static friction, or the applied force, is the 260. Static friction would be mu Fn. I would use this static coefficient. Normal is 500, so this is 250. So this is the max static friction. So if this is the static friction force and I push it with 260, that is enough to overcome it, so it does not remain at rest. It will start to move, and because you have a greater force, it will start to accelerate. So it's going to accelerate to the right. Give an expression for the applied force needed to keep at a constant speed. Constant speed tells me that the forces are going to be balanced. We've got friction and use G. So here I've got force of gravity and normal force. And then I've got some applied force and a friction force. And this is at a constant speed, so they're all going to be equal. Fn equals Fg, and Fa is equal to force of friction, mg, and this is mu Fn. Fn we just said was mg, so this is mu mg. We're looking for the applied force, this is our answer. But I need to decide which coefficient it is. So here, you've got to pay attention to what it says. It says the force needed to keep the object at a constant speed. That is not starting it moving, that is keeping it moving, so that is already moving, which means I would use the kinetic coefficient of friction, which would be mu k. Here we've got a mass of m on top of a mass of 2m that is in an elevator. The elevator is moving up in speeding, so that means the acceleration is up. I want to draw the free body diagram for each of them. So I know for sure, so this is my m, this is my 2m. I know for sure they both feel the force of gravity. I can start with that. I know that there is the force of the floor on the bottom box. So if we're looking at our diagram, so the floor is touching the bottom box. The floor is not touching box M, so I shouldn't have anything with floor here. But this one, the floor is pushing on the 2M up. So we are drawing, this is a floor. We are drawing the forces on the 2M, so the floor is pushing the 2M up. Now we are talking about the force between the two boxes, so the top on the bottom and the bottom on the top, it's the same force. This is the F box. The M is going to be pushing down on the 2M, so on the 2M I have F box down. And then the 2M is going to be pushing up on the M, so on the M I should have F box up. These need to be accelerating up, so I've drawn this force greater and this force greater than the two of them combined. Now we write our F net equations. Bigger minus smaller, always. Replace. Get F box by itself. F floor minus 2mg. Make sure you distribute. This is subtracting both of them, so it becomes minus ma and minus mg. Add this ma over, becomes 3ma. These two combine to negative 3mg, add it over, becomes plus 3mg. And there's your answer, because we were asked to find the force of the floor. Here, same idea, but now it is moving upwards and getting slower. So I'm going to draw the exact same forces. The M still has just the force of gravity and the box force, but now it's accelerating down, so Fg is greater. The 2M still feels its own force of gravity, still feels the box force down, and it feels the force of the floor up, but again, it is accelerating down, so these forces are smaller. Writing our F net equation is going to be super similar, just opposite order, because we always do bigger minus smaller, so that would be Fg minus F box here. And this one, I have two combined, so the Fg plus the F box, and then subtract the opposite one, so subtract the smaller, the F floor. Replace. I did this a couple different ways. So I'm going to add F box over and subtract this one. So if I add F box over, I would need to subtract the MA. So this would be mg minus MA. Replace F box. This is 2mg plus F box, which is the mg minus MA, minus F4 equals 2MA. I need to add the floor over. This right here becomes 3mg. I add the floor over, now it's over here, and I would subtract the 2ma over, so that would be negative ma minus 2ma is negative 3ma. And then this one, it makes sense that I have subtraction sign, because if it wasn't accelerating, then the force of the floor would just be holding up the total weight, the 3mg, so the 3m's, and then obviously make it a force, g. So it would be holding up the weight, but because it is accelerating down, it's not holding up all the weight, it's holding up less than the weight, so it's subtracted. Whereas before, you were holding up the weight, the 3mg, and accelerating upwards in that same direction, so it was greater than if it was just at rest. Here, so for sure I have the two forces of gravity. It says M2 is greater, so I'm going to draw that one a little bit bigger. Don't know how big they are, but that one has a greater force of gravity. There's obviously this applied force acting on the 1M. and then there is this tension force right here. That tension is pulling down on the M1 and pulling up on the M2. So the M2 would have a tension